Try this algebra problem.
Here we have a system of equations in 3 variables, and if we want to solve this system, what we first need to do is find terms in our equations that have opposite coefficients. Here I have a negative 4y, this is a positive 4y. We can add these two equations together to get rid of y. If we do that, we'll get 5x plus 3z equals 1. After that, we want to take any equation we haven't used, the third one, and then eliminate that same variable. We can do that by multiplying this first equation by 3, this equation by negative 4, and then adding those equations together. That'll give us 6x plus 12y plus 3z equals 48. Second equation, negative 8x minus 12y minus 20z equals negative 80. Add these together, we'll get negative 2x, these go away, minus 17z equals negative 32. Now we have two equations with the same variables. We're going to solve one of these equations for one variable. Let's solve this one for x. Add 17z to both sides. Divide both sides by negative 2. We get x equals 16 minus 17 over 2z. Now that we have this, we're going to plug it in for x here. We get 5 times 16 minus 17 over 2z plus 3z equals 1. Now we have one equation with one variable. We can solve this for z. We get 80 minus 85 over 2z plus 3z equals 1. I'm going to subtract 80 from both sides. Now I'm going to multiply this whole equation by 2 to get rid of this fraction. We can combine our like terms. We'll get negative 79z equals negative 158. Divide both sides by negative 79. And we get z equals 2. Now we can take z, plug it back into this equation to solve for x. We get 16 minus 17 over 2 times 2. We get 16 minus 17, which is negative 1. Now we'll plug in what we found for x and z into any equation we started with to solve for y. Let's use the first one. Combine our like terms. We get negative 4y plus 1 equals negative 15. Subtract 1 from both sides. We get negative 4y equals negative 16. Divide both sides by negative 4. And we get y equals 4. So our final answer is the ordered triple, negative 1, 4, 2.